I want you to take out your phone and take a photo. Now zoom in again. Eventually, the image stops looking like a photo. The smooth curves of a face turn into jagged squares. The colors separate into blocks. You have hit the resolution limit of the screen. You have found the pixels. Now, I want you to look at your hand. Zoom in. You see skin. Zoom in. You see cells. Zoom in. You see DNA. Zoom in. You see atoms. For centuries, scientists assumed that space was smooth. They thought you could keep zooming in forever. They thought reality was continuous, like a ramp. But quantum mechanics tells us that this is wrong. There is a limit. There is a hard stop. Deep down, at the very bottom of reality, the universe becomes pixelated. This limit is called the Planck Length, and its existence suggests that we might be living in a digital simulation. To understand the Planck Length, you have to understand scale. It is 1.6 times 10 to the power of negative 35 meters. That number is so small it is meaningless to the human brain. So let me give you an analogy. Imagine a single atom. Now, imagine you blow that atom up until it is the size of the entire observable universe. Inside that universe-sized atom, the Planck length would be the size of a single tree on Earth. It is the smallest possible measurement. In physics, it is impossible to measure anything smaller than this distance. It is impossible to move half a Planck length. This means that motion itself is an illusion. When you wave your hand, it doesn't move smoothly through space. It teleports. It jumps from one Planck coordinate to the next Planck coordinate. Like a character moving across a chessboard. Space is not a smooth fabric. It is a grid. Why does this matter? Why should you care about tiny pixels? Because pixelation is the hallmark of a computer. A computer cannot process infinite data. It has finite memory. It has finite processing power. To save resources, a computer must set a minimum grid size. In a video game, you can't make an object smaller than one polygon. The Planck length looks exactly like the grid size of our universe. If our universe was a natural analog reality, it should be smooth. It should be infinite. But if it is discrete, if it is made of blocks, it suggests it was engineered. It suggests it is code. Scientists aren't just philosophizing about this. They are trying to find the pixels. At Fermilab in Chicago, they built a machine called the Holometer. It is a laser interferometer designed to measure the jitter of space-time. Think of it like driving a car. If you drive on a newly paved road, the ride is quiet. But if you drive on gravel, the car vibrates. The holometer shoots lasers down massive tubes to see if the laser light vibrates as it moves across the quantum grid. They are listening for the hum of the simulation server. So far, the results are inconclusive. But the fact that we are even asking the question, what is the resolution of reality, is a turning point in human history. There is one more piece of evidence, and it is hidden in the math. In the 2000s, a theoretical physicist named Sylvester James Gates was studying superstring theory, the math that describes the fundamental forces of nature. Buried deep in the equations, he found something that shouldn't be there. He found a specific type of code called doubly even self-dual linear binary error-correcting block code. That is a mouthful. But computer scientists know exactly what it is. It is the code used by search engines and browsers to check for errors in data transmission. It is computer code, written into the laws of physics. Why would the universe need error correction unless it was processing data? Why would gravity and electromagnetism contain the same logic as a web browser? If the universe is pixelated, it changes everything. It means you are not just a biological organism. You are a complex pattern of information processing on a 3D grid. Your thoughts are algorithms. Your feelings are subroutines. And the laws of physics, the speed of light, gravity, thermodynamics, are just the operating system limitations. The speed of light is simply the maximum rendering speed of the processor. Black holes are just places where the code divides by zero and crashes. It is a terrifying thought. It makes us feel small. It makes us feel fake. But it is also exciting, because if reality is code, code can be hacked. Maybe in the future, we won't just study the universe. We will learn to rewrite it. We will learn to access the command console. We will learn to change the variables. We might even learn how to escape the simulation and meet the programmer. So look at your hand again. It looks solid. It feels real. But deep down, quadrillions of times smaller than an atom, it is just a cloud of geometry. It is just a set of coordinates blinking on and off. You are the most advanced video game character ever built, and the game is beautiful. I am your host. Check your resolution. subscribe.